Okay, it doesn't look like anyone else has joined, so we'll get started and begin. So first of all, thanks a lot for joining this training session and for signing up and joining on Monday morning. So this is the first session in a 5-day training course, which we'll be going through from Monday to Friday. And it's also part of a wider event around the Inif Core Hackathon. And I'm sure you may all be aware of this, but if you want to check out the full schedule for the hackathon, just head over to the Inif Core website and you can find information there. So we're going to be doing training sessions in the morning for 2 hours. And in the afternoon, you'll find talks and then the rest of the hackathon to work on in time. But assuming that you're all here in the right place, you're here for the training. And what we're going to be doing is running through everything, hopefully to get you started with Nextflow and bring you up to speed with everything. So today we're going to begin with a presentation around 45 minutes or so, where we're going to introduce Nextflow, the kind of concepts behind it, why it was created, and then give you a kind of overview of the Nextflow ecosystem and of everything that's sort of involved in Nextflow. And then in the second part of the session, we're going to set up our environment. So we're going to be using a cloud environment for those of you who are participating on Zoom, set you up on AWS, download the materials, the course materials that we need to run the course, and then get started with a first Nextflow script, just to begin from the beginning and understand the simple concepts. Tomorrow we'll jump in and do Nextflow scripting. So we will look at the basic concepts of Nextflow. We will go through what are channels, what are operators, what are Nextflow processes, and the kind of language syntax that's used to write Nextflow pipelines. So very much focused on writing the pipelines themselves. And we will finish that section on Wednesday morning, where we will write a very basic RNA-seq pipeline using 4 or 5 steps, which will bring together all of the individual components that we've learned from the first couple of sessions. Then on Thursday, we'll switch gear a bit, and Thursday and Friday will be not so much on how to write the pipelines, but how we can configure them and how we can deploy them in different environments. So we will do a session first off on containers, how we can build these containers, how we can use them in Nextflow pipelines. We'll look at Nextflow configuration. So run through how we can configure our pipelines, how we can use Nextflow configuration to very clearly separate the workflow logic from the execution. And then we'll do a small section on cloud deployment, how we can deploy these pipelines in the cloud. Also a small section on batch deployments using, for example, schedulers like Slurm. And we'll finish off with a section on DSL2 and how we can write modular Nextflow pipelines, followed by a hands-on explanation. We will share all this material with you. So from the top, a brief introduction is probably necessary. So my name is Evan Floden. I'm the CEO and co-founder of Sakera Labs. Also on in this part of the training session, we also have Paolo Di Tommaso here. So Paolo is the creator and the main developer of Nextflow. And together we formed Sakera Labs a couple of years ago now, really to strengthen the Nextflow ecosystem and be able to kind of work on it full time, build it out, make it a sustainable place to build pipelines. The origins of Nextflow date back to our time at the CRG, so the Center of Genomic Regulation in Barcelona, where we were working together back in 2013. Paolo started working on Nextflow, and we were in the lab together working on multiple sequence alignment. So creating many iterations of analyses for very large data sets. And essentially the problem was the cluster was sometimes busy. Could we take the analysis that we'd written in one system for doing these large analysis and then run them in the cloud? And sort of overcoming that challenge is, and iteration on that, working towards being able to do that, just it turned out that a lot of people had the same problem. People were dealing with larger data sets, moving to cloud, etc. And that's the kind of origins of how Nextflow came about, and sort of the rest is history. So going through what is a data analysis pipeline, so what are we really doing with all this? So typically, I think if you have some experience in bioinformatics, you have a feeling of what a pipeline is. You often write these yourself. These were typically bash scripts or commands that you would type in a series from the command line. And you essentially have many different steps. Each one is typically a piece of software or a script that you have written. And the data has to go from one step to the other. And sometimes you have to combine that data. Sometimes you have to separate it. You have to analyze it, and then you get some kind of report or some output, which hopefully you can make something actionable on or use in your analysis. And this is a very much an idealized view that we have here on the screen. So in reality, though, it's typically not this uniform. And I'll show you an example of a more less stylized example here. This is a genome annotation pipeline. You can see each of those individual steps is a script or a piece of software. And in real life, in our real work, these things become very messy. So we have a very complex pipelines, and the pipelines that we see getting developed can become increasingly complex in the tasks that we're trying to do as the data becomes more complex, and the analysis that we try to run does as well. So if we think about this, there is what we can use Nextflow for and what we don't necessarily use Nextflow for. We like to think of it as a lot of our pipelines could be, in one sense, academic, in a pure academic sense, where I just run the pipeline once, say, and I use it purely just for a single analysis, all the way through to something which is clinical, which gets run in production hundreds of times, thousands of times. And then another angle you could think of it as where there's something as a batch or a high throughput analysis. So where you have many tasks which need to be distributed across cluster or cloud, versus the other idea of something being interactive. Like imagine that I have some downstream analysis where I'm generating a figure, or I'm iterating on some data I need to kind of provide some input. So where Nextflow is focused is pretty much all the way across here, except for the interactive analysis. So Nextflow is not particularly well suited to specifically iterating over something in an interactive manner. We're much more interested in that kind of high throughput, but anywhere between running something once and running something thousands of times, anywhere between academic and clinical production, it's well suited for. And in these situations, so what is the commonality here? Why does Nextflow work in these situations? Because what we've observed is that people have large data sets, typically in bioinformatics and genomics and in all data analysis now, we have increasingly large data sets, which are bulky. They're difficult to deal with. We can split our tasks up, either splitting the data up or the tasks that we need to run, in what's called an embarrassing parallelization. So we can split the task into hundreds or hundreds of thousands of jobs and then run them in a distributed manner. This means that we can run them over cloud, where we have virtually unlimited resources, or we submit them as jobs to our cluster, where we have a distributed compute. And we also have to combine this in parallelization with the fact that we have many different tools in our pipeline. In the one I showed you before, there was 70 different scripts, many different dependencies, and managing the complexity of those pipelines and the dependencies becomes very difficult. It creates what's called a complex dependency tree. So having to install all of that software into one system, one environment becomes incredibly difficult. And then it becomes very difficult to both maintain that, but also to update that. And to get that portable becomes almost impossible. A final thing that we see now is also the different resources that are required for different tools. So sometimes you may be indexing and you need a lot of memory, or at other times when you have tens of thousands of samples, which you need to just split across many CPUs. And this mashup combined with the fact that increasingly we're seeing people using accelerated analysis, so using GPUs, for example. All of this as well adds to the complexity of managing the pipeline. And we have really a lot of moving parts in this. So as I said before, the example had 70 different tasks, many different internal scripts, and different software which needed to be installed. So managing that becomes incredibly difficult. And Nextflow is really trying to solve for this by providing a system which allows you to control all of these parts and run them in a different way. We were very interested in early on, and this was a few years ago now, on the reproducibility aspect of this. So being able to ensure that you can get the same result across different analyses, or across different runs or environments. And this is a publication here which showed you that just to read a typical bioinformatics paper or computational biology and to reproduce that result took something like 280 hours. And that's when you have all of the methods, when you have all of the input data, etc. And that becomes incredibly challenging. You think this is a lot of waste of time. We have a jigsaw puzzle essentially that we're trying to re-put together for every system that we're trying to run our analysis on. In a way, this seems kind of crazy. You think it should be far more automated than this. And a problem is that even when you do have the same application, even when you do have all of the parts, it's not necessary that you'll get the same result. And we were able to show in this paper, so the actual Nextflow paper in Nature Biotech a couple of years ago now, that even with the same analysis, you can end up with different results on different machines, just due to underlying variances in the libraries. So for example, here, we showed that genome annotation pipeline, you were getting genes being annotated in different locations. So start positions being different. We looked at some very common transcript quantification tools. So this is Callisto and Sleuth, and showed that when you did this with Mac versus Linux, you ended up with different genes being called significantly different. And this is just this is with the same version of the software, just using different operating systems. This can also be shown down here. This is a table of the same data. What we also see is that the reproducibility was just a small aspect of this, and it was the kind of the starting point, which we were obviously able to control with containers, which I'll show you in a moment. But the reproducibility was really just a small part of the puzzle, which we're trying to solve in simplifying this data analysis to the cloud and really bringing bioinformatics workflows to the cloud. So we're also very focused on the portability. So this is that I can essentially collaborate with my teammates. Can I share this pipeline and they can run it on their different environment, on their cluster, on their cloud? Can I be scalable? Can I take my pipeline and create a small test data set to be able to develop code, iterate very fast, and then also be able to take that exact same pipeline with the same code and then run it in a scalable manner? This means, can I take it and run it into the cloud, for example, or into the cluster? Can I ensure my pipeline is validated? Can I have some kind of conformance associated with a particular run? Can I track all of the code, be guaranteed to get the same result? And can I make my code usable? We kind of envision a world where developers of these pipelines are really not the main users of them, where the pipelines can be used both by anyone in the lab, regardless of skill level, all the way up to, at the other end of the spectrum, people who want to integrate their pipelines into more complex systems. And this comes down to the full automation of the pipeline, so push the button pipelines. And there's some kind of pushback against this. You can imagine that people say, we need to know exactly what's in the pipeline, or how every step runs. And we don't want to say push the button in a kind of non-transparent way. We really mean automating and making the most of the current software engineering practices and tools that are available to make these pipelines be able to fit into the modern systems that we've developed. And our solution to this is, of course, Nextflow. And now I want to introduce the kind of core concepts of Nextflow, which we'll see over the next few days. So Nextflow is both a programming language and it's also a runtime. So this is slightly different from some of the other workflow systems you may have heard of. So if you imagine something like CWL, which is a specification, you could think of it kind of like a language. And then there's also a runtime, which is like the different runners that they have. In Nextflow, this is separated out in this way. So we write our code in any language. This means that we essentially write in what we call processes. And we can use any scripting language to do this. So R, Python, Bash, anything you can think of, you can just call from a Nextflow process. We also then connect these processes up with what's called data flow programming. And this is where Nextflow channels become very important. So we can take each process and link them together. And we also define the software dependencies for each of those processes, typically using containers. So Docker, Singularity, Podman, and also Conda. Conda is supported. And the Nextflow script itself is completely version controlled. So by default, but just by the fact that you create a Nextflow script, we build in Git version control into the system. This allows us to have a pure definition of the Nextflow script, which is separate from the actual runtime itself. So when we run a Nextflow script, we can then submit that same script onto, or that same workflow onto very many different executors. So the main cloud executors we have is for AWS Batch, for Google Life Sciences, and for around 10 of the most prominent traditional batch schedulers. So for example, Slurm, Inif, Grid Engine, LSF, etc. It's also obviously support for running your pipeline locally, just on a single machine, and also support for running in Kubernetes. So how does this work? So this is the kind of fundamental core components of what a Nextflow pipeline is and how you can run them. There's also a few, I guess, fundamental parts to how it works itself. So another thing that's different about Nextflow is it's a custom DSL. This means a domain-specific language. And it means that it's a syntax that has been created on top of another programming language. So we have a way that we can write our pipelines relatively fast and prototype very quickly. We can define our processes. We can define the core things that we need to do to write the pipeline. But we also have access to this general purpose programming language for the corner cases. This means that if we're stuck in a situation that we need to write some custom piece of code because it's, we're doing something particularly unique, we're not limited by the DSL. The programming language that we use, that Nextflow is written on top of, is Groovy, which can be thought of as a kind of Python for Java. It also allows us to then access underlying Java. If you're a more advanced programmer, you can access all of the Java underlying that if you need to. Nextflow uses a data flow programming model, and this allows us to get parallelization implicit from the way that we define the pipeline. I'll show some examples of this. It's better seen by looking at it, but it allows us to very quickly create pipelines by connecting up the parts, and this implicit parallelization scales incredibly well versus something like a make approach, where there's quite a few issues around building very large pipelines in that way. Another very important part is this self-contained idea, the idea that every single task itself is independent. It lives in its own working directory. And this was really kind of key when we think about how these tasks are now executed in the different cloud environments or executed as containers. Because each Nextflow job lives in its own working directory, it can be thought of as a container execution, a container run command. You can think of it like this. And this way we can split up our workflow and we can have each of the individual tasks running in completely different infrastructure. I can run some of my pipeline on my cluster. I can send some of it out to the cloud. It doesn't matter from Nextflow's perspective because it's able to send these things across different environments. And finally, the most important part is that we very much separate out the workflow logic, so the Nextflow syntax that we write, from where we deploy these pipelines. So where we send these pipelines onto different environments. And keeping these things separate is really crucial to making the pipelines portable. How does it look like? So this is a typical example that you may see in bioinformatics. This is a command line tool that we're running. So this is BWMem. And we're simply taking this sample and aligning it against a reference, piping it to SAM tools. One of the key things with Nextflow is that we didn't want people to have to rewrite their pipelines. So we want to keep the same pipelines that you've got. It makes it easy to re-implement them into Nextflow. And what we do is we wrap the existing code that you have, or we wrap the command that you want to run into what's called a process block in the first case. So this is the same task that we had before. You'll notice it's in the script section. We have to define a process. In this case, it's called align sample. We define the inputs for that process, the outputs for that process, and the script section. Now, one thing to note here is the use of channels. You can see that we have 3 channels defined here, 2 in the input, so from genome channel, from reads channel. And it's the channels which allow us to compose multiple tasks together, channels which link the processes together. Consider that I wanted to use this as an upstream task to a task that's downstream. I want to use the output of this. Imagine that I want to use this now sorted BAM file, so the sample.bam, in the downstream task. What I do is I take the output channel, so here the BAM channel, and it simply becomes the input of my next process. So imagine that I wanted to now take that BAM file and use SAM tools to create an index from it. The fact that the input here the output of the align sample links to the index sample creates this implicit linking. And it's this implicit linking all the way through your pipeline, this connection of these channels, which provides us with this data flow model. So these channels are first in, first out queues, the asynchronous first in, first out queues. And they are what we can use to implicitly define what a process's input and outputs are. In practice, what does it look like? You can imagine that a channel could contain three elements here. This could be 3 files, data z, y, x here. And the language that we use is that we have a channel containing 3 elements. We have a process, which in this case takes the channel as input. And the fact that this channel takes 3 elements as input would result in the fact that we have 3 tasks of that process being run for each of the data. And then you end up having, of course, the output of each of those tasks, which will then be into a new channel we can use in a downstream process from here. Maybe it's better to see this in practice. Consider this process here. This is a Nextflow process for FastQC. And you can see that the first case, we're just filling the samples channel, or we're defining the samples channel with a single sample. So sample.fastq. When we run this pipeline, you would see that the input of the FastQC channel is simply the samples channel. This means that the FastQC channel would only run once because we have 1 sample in the channel. We have 1 element in the channel. If we were to change this now though, and now we were to say, okay, don't just have a single FastQ in that channel, have every FastQ that exists in that directory. Now, the fact that the channel contains every FASTQ, the process would run however many FASTQ files we had in that directory. And this parallelization continues through the pipeline. So, for example, imagine that we had a downstream process from here, from FastQC channel here. This next process will be able to run as many times as we had that. And we have ways of combining the elements in channels, of splitting the elements in channels and manipulating them. And that's what we're going to spend a lot of the time on tomorrow looking at. This is just another visualized view of that. So for every FastQ file that we had here, we would have the FastQC process running. We also have ways of handling more than a single element, more than a single file inside an element. So very often we have pairs of files that we have, or pairs of values. In this case, we have a channel factory, which is called from file pairs. And it allows us to group pairs of files based on a common key. So in this case, we have gut, liver, and lung samples. So we have 6 files, but there's 3 samples there. And what this channel factory does is look for the common part, in this case, gut, liver, and lung. And it's going to create a channel, which is now having elements that are a tuple. So this channel contains 3 elements, and each element is a tuple made up of a sample ID and the files themselves. So this allows us to kind of group these together and then run them as a sample. So imagine that we wanted to align these samples. We could have them, each of these would run once into our process, depending on how we defined it. It also is quite neat in that it allows us to pass some metadata around in the channel. So the channels don't have to be files. They can be any data structure. In this case, it's simply a string made up of gut, lung, and liver, our sample ID. But it can be more complex as you want. So that was very brief, 20 minutes on the Nextflow syntax. We're going to go a lot deeper into how all of this works. And how we can actually use it to write our pipelines. But next up, I just want to jump in and talk about the deployment of the pipelines now. So now I'm stepping away from the language syntax and onto the deployment. We have several ways of running our pipeline. The most basic is just when you say Nextflow run with no configuration, you run your pipeline on your local machine. So this is either with or without containers, as you prefer, but you're running on the underlying host operating system, connecting them with local storage, and the pipeline just runs with each process as just a POSIX process. Sorry, each task is a POSIX process there. This can be useful for developing your pipeline. Typically, you want to develop very fast. You don't want to distribute those jobs out. You want to know if it's failing quickly. So that helps you a lot. In this regard, also situations where you want to do a small test of your pipeline, or you want to have some kind of continuous integration that runs on a small test data set. This is a very useful way of running just with the local execution. Another very common way of running is the centralized orchestration method. And in this way, Nextflow is submitting each job to the cluster. Typically, this could be with a Slurm job or a Inif grid engine job, and Nextflow takes care of the submission of each one. So you can specify the resources in one way, but you don't have to specify the resources specifically for each compute environment. So Nextflow is able to translate the resources that you require. This allows you to write the pipeline in a portable way. And we'll see a lot more of that in the configuration section. A small way you can also run Nextflow as a job itself, which is able to spawn jobs, not so widely used. But what's become incredibly popular is kind of the batch execution in the cloud. And this has come about via 2 services in particular. One is called AWS Batch, which you can see here. And what happens with AWS Batch is it's very similar to having your own HPC sort of on-premise cluster system. And Nextflow submits each task to AWS Batch via the Batch API. This will contain information like the resources that are required, but it submits each task as a containerized job execution. So you say for each task, it's going to say which container is required, what the command is to actually run, what the script is to run, and what the inputs, etc. are. Batch will then spin up a virtual machine that's required with the right resources. When that virtual machine is ready, the job will be run. The containerized job will be run. The input data that's required will be passed from an S3 bucket to the virtual machine. The job will be run. The output data will then be passed back to an S3 bucket. And then the VM can essentially close down. And this is great because it means you only pay for what compute you use. So this can be sometimes, literally your job can run for seconds, and that's all that you will pay for. But it still enables you to have the full power. So you can, if you have tens of thousands of samples now, run this in a very efficient way. And in terms of the pricing, particularly using spot instances, it's starting to look very competitive against having your own batch and on-premise system. There's also ways of doing this in a kind of even more native way without having to use S3 buckets. You can have a shared file system. So this is FSX for Lustre. This enables you to debug in a quicker way, and also for the pipeline to run faster, because it means that the FSX system is tied into each of the VMs. So it's much more like having a shared file system that you traditionally don't have in the cloud. Similar, there's another system for doing this on Google, and this is called Google Life Sciences. It works in a very similar way. The concepts are extremely similar. It's just a containerized job. The difference here is that Batch has a slightly more sophisticated way of essentially scheduling the jobs, and is able to schedule multiple jobs or tasks onto a single VM, whereas Google Life Sciences, the mapping is one-to-one. So it can be a slightly longer startup time depending on how you're running that. And of course, we have support for Kubernetes as well. This becomes quite popular for people with larger infrastructure, or if you already have a Kubernetes cluster set up. This is how Nextflow runs each task as a pod inside there. In practice, we have Nextflow Script. And the idea is that any Nextflow script that you have, if you just run it locally, you're going to be running it on your machine. The same Nextflow script, though, if we want to run this, say, on the cluster, we would simply change not the script itself, but the config. So we would write a piece of config. We would say, okay, to run on my Slurm cluster, I need to define a queue, some memory, some CPUs, and a container image. And this would be, say, running on Slurm with Singularity. If I was then to take the same pipeline, remember, we haven't changed any code in the pipeline here, just the config, and I wanted to run this, for example, on AWS Batch, I would do the exact same thing here, except the only thing I would swap out is the executor here. So what you'll notice is that the abstractions are the same. So whether you run on any of the batch schedulers or in the cloud, you have the same concept of what a queue is. You have the same concept of what memory is, a CPU is, or a container is. And this allows us to write the pipelines in a portable way, because typically the amount of memory we would need would be sort of independent of the system that we have. But it provides us this flexibility, and by providing the right abstraction, we're able to do this in a kind of portable way, and kind of getting all the benefits that we discussed earlier on. This is just to stress this one more time. It's really this decoupling of the workflow logic from the configuration, which is really key to getting this portability. What has really enabled us to do this, though, and to do many of the things we've done in Nextflow is the use of containers. So containerization became very much popular, starting off with sort of web services around 2012, 2013, and that was just the same time that Nextflow was getting started. And Paolo had some very nice insights early on to be able to see that we could take and consider the way that people were using containers for web services and apply them for bioinformatics. So Traditionally, there was some use of virtual machines, but containers had several advantages over them. So they were much smaller, typically be some in the order of megabytes versus several gigabytes. Very much faster to start up. So you can spin these up very quickly. You don't have to wait for minutes for your virtual machine to get going. We have the ability to virtualize the process instead of all of the operating system and the hardware. The containers are immutable. This means that they don't change over time. It means that every time I start them up, every time I start a container, I can be guaranteed of the state that it is in. So I know that it hasn't changed. And then I can think of it as composable. So I can use layers and I can build a container from another container. This is super useful for creating optimized containers for smaller containers. And they're transparent. We have all of these really nice tooling now around containers that we can use to build them and to manage them. So how does it work in Nextflow? We considered that we had support for Docker very early on in 2014. And then more recently, there's been other container technologies such as Singularity, and recent one is Podman. And what that enables us to do is it just removes some of the security concerns. So then Singularity, for example, is much more focused on running containers in cluster. We'll see on Thursday that this is not a real issue for us, though. We can think about building our containers once, and there's really good compatibility across the container technologies, which helps us out a lot here. So each Nextflow task, when it's submitted, so you can think of this as each job, is submitted as a container run command. And this really fits in well with how containers are envisioned and really was sort of preempting the use of AWS Batch in its initial development. I hope that one thing you can take out of this workshop is when to use containers would be always. Once you start using containers and become comfortable with building them, I can guarantee you'll never go back to installing software manually again, because it's just such a huge benefit to your work and speeds up all of the DevOpsy side of things. I remember when I was getting into bioinformatics that it was typical to spend so much time just installing software and then sort of not necessarily recording the way that I've installed the software in a kind of reproducible way or in a way that was particularly transparent. The building of containers automates that whole process for us and ensures that we can spend a lot more of our time thinking about the bioinformatics tasks that we're working on and a lot less time on actually having to deal with that. A few more things now on some other related Nextflow ecosystem stuff. So Nextflow is collecting all of the information on the resources that are requested and used. This stuff has now been a little bit outdated by Tower, which I'll show you in a moment, but it's good to know that Nextflow has some execution reports, so you can go through and see the resources that are required, and it's collecting all of this information in the background. So, for example, if you requested 40 gig of memory and used 48, and you can see how that's been used across your tasks. Likewise with the time, how much time is being used by each process. This is useful to understand maybe bottlenecks or pieces that you should optimize. You can create visualizations of the tasks, so of the pipeline itself. And there is some useful syntax highlighting that's available in some of the editors. So this is useful for being able to see your pipeline more easily and running that. Nextflow also has support for Nextflow itself for Global Alliance Genomics and Health. So this is a consortium of several different industry and academic groups. Nextflow has support for the task execution API. This is an API for being able to run different tasks on different executors across the different workflow systems. So for example, CWL and WDL. And there's also another API which we've just added support for the last week actually, which is the WES API. And this is for workflow execution. And this is done via Nextflow Tower. So it allows there to be multiple execution engines for running Nextflow pipelines, and Nextflow Tower is the first one to support this. In terms of the user community, so the last couple of years has seen dramatic growth in the Nextflow community. As I said, the project started way back in 2013, so it was a lot of work over very many years before the kind of more recent adoption which has come about. And this is really driven by the community itself. A lot of very important work by different contributors, by the people developing pipelines, by discussions on Twitter, who's kind of drawn out this and kind of get this feedback in and a kind of feedback loop going in terms of the development of the pipelines. This has led to adoption across industry as well. So Nextflow users are still probably the majority are in academic, but the use is also spreading into industry. And a big part of that success as well is down to the community, and particularly Inif core. And it's a way to come up with standards for developing the pipelines, the tooling around development of pipelines, and most importantly, a really good community of amazing people who work incredibly hard in a kind of also very fun manner to develop these pipelines, which become very much ready to use. So recently, both Nextflow and Inif core received a joint grant from the Chang Zuckerberg Initiative for essential open source software and science. So there'll be some very cool things coming out of this over the next year or so as well. And hopefully this can continue very much in this way. So whilst Nextflow is, you can see that we have a runtime, we have a way of running these pipelines in different execution engines, and we have a kind of language which provides us with this portability, ease of use of containers. There were still some limitations associated with it, in the sense that it's a single user, single execution command line tool. And we wanted to think about some of the high level functions. People had been asking us for many years about how can we create a user interface? How can we create a place to log out of pipelines? How can we connect in external tools and external systems into this? And we'll take a break in 10 minutes or so, but I'd just like to do a quick introduction of Nextflow Tower and how this fits in to the ecosystem. So we created Nextflow Tower and released this at the end of last year. And Nextflow Tower is a full stack web application for the management, execution, optimization of your Nextflow pipelines. So I'm just going to share my screen now. You can find Nextflow Tower over at tower.nf. It's free to use. So there is a cloud service, which is free to use. You can run a couple of pipelines at a time over there. I'm going to just change over my screen now to give you a quick demo of how this works. Just hold with me a second. Okay. Okay. So I'll just log out over here. So you can see this tower.nf that's available. You can sign in with GitHub. When you sign in here, you're greeted with a screen. You can see on the left-hand side, I have a history of my executions that I've run. So these are just color-coded depending on the state that they're in. And for each pipeline that I have information on the actual pipeline I ran. So all Nextflow pipelines are from GitHub, or can be, supported by Git. So this is just a project we call. We have a run name, and then we can see the command line that was actually used, some parameters associated with that, some configuration, and an execution log. So this is the actual code when I run through. But the kind of the cool things that's coming out about this and how we can run this, we can see information on general statistics, so how long it ran for, the resources that I used, the cost that it cost me, utilization. And for each task, we're recording this information. So I can jump in now and see on this index task the exact code which was run here. I can go through and see this. I can see information on the resources that were requested, the resources that were used, etc. And having a full database of that execution is very important. The other thing that we've been able to do more recently is actually launch pipelines from this environment. And this enables us to not necessarily have to use the command line, but also be able to automate many of the processes that we run for running these pipelines. So I can launch a pipeline. I can choose any of the environments that I have set up. These are what we call compute environments. These are, you can think of it as like config for where you execute your pipeline. I could choose any pipeline here. In this case, I'm just going to run a very quick one so we can see this. We have a concept of a revision. This could be a commit or a branch or a tag. By default, you don't need to have this. I'm just going to run the default one. And I can choose some config profile or some params. When I launch this, in the first instance, the Nextflow job itself, so the Nextflow run command that you can see here, will be submitted to AWS Batch as a job. And then from there, the other jobs will be submitted onward from that. We also have, as part of Tower, many several kind of features which we're adding into here. So you can manage your compute environments to be able to create, for example, all the AWS resources on the fly. So if I was going to say some resources that were required, so my AWS Batch here, I can choose a platform. If I put in some credentials here, select a region, say select a region that I want, could place in here a working directory, etc. With Batch Forge, this will create all of the resources that are required. So there was many difficulties with setting up cloud environments previously. People were struggling a lot because it's not a particularly easy thing to do, even for advanced users. So with the new features, and this enables you to create all of this on the fly. There's also managing credentials, so you can have support for all of the main Git providers here. This allows you to run your pipelines privately, so private repos that you have, as well as your credentials for the cloud providers, and obviously more coming here. Some of the other nice features is pipeline actions. So we talked a bit before about how we can automate this process, so how we can really automate the development of our pipelines. And pipeline actions is really a key part of doing this. So with here, we can create a new action. This is a way that we can either use an event to trigger a pipeline. So this event could be, for example, a GitHub webhook. This means based on a Git event, a commit, or it could even be a hook here. So we can create now a launch hook. That means that we can create a pipeline. So let's say it's the same pipeline, choose a revision like this here. When I create this now, I now have a way of triggering this pipeline execution based on this curl, for example, the curl command tool. So this is just a way of triggering it via the API. This means that I can say, put some parameters in here for my pipeline and launch this and build this into other systems. Just go back and share the screen now and talk about some of those other things that we have coming. So the architecture for this is very much based on what Nextflow is based on. So you can launch a pipeline from your laptop. It can be running in the cloud or in your cluster, and you can monitor it from your cell phone. We wanted to keep this kind of really platform agnostic view with Nextflow Tower. The majority of people are deploying this in cloud, typically in AWS, but it can be deployed anywhere. So on premise, and the kind of Kubernetes is the main deployment option here. It really operates in the same way in Nextflow. So you can have your runtime, you execute these, and Nextflow, at the moment, we have support for cloud execution, but we're adding support for all of the Nextflow executors in the coming weeks. So this can also be done on Google as required. We now have the ability to monitor these pipelines, launch them, and we can use cloud native storage. Now, the other things that we're going to be working on is the ability to collaborate. So have a team structure here so that you can launch your pipelines and that your colleagues can view the status of them, that we can take these pipelines, and at the moment we have many different containers as part of the development process for some larger pipelines. So building these containers on the fly and automating that process, as well as validating that process. So if I bump a single version of a container, I want to be ensured that the output I get is something biologically relevant, that changing my software, I can run a full test, for example, that provides me with an output which is valid, as well as the accounting, team budgeting, etc. Cloud costs become quite a complex topic to get into. So understanding that and helping users keep control of their cloud costs becomes very important. The whole thing is API driven, so anything you can do from the user interface can also be controlled from API. And this allows people to build in Tower to their existing systems. And for example, you can imagine events where the triggering of a pipeline is based on the deposit of data in S3 bucket, which could come directly from an Illumina machine, for example, and then all of the downstream steps that occur from that. So everything in here is trying to make life easier of people developing these pipelines for use. So that's the end of the sort of section on Tower. Now we're going to jump into the actual training session and training environment part. Just a summary on that. What we show you here, what we learn with Nextflow, it's not necessarily going to provide you with all of these things for free. You still have to dive in and learn a bit, but it provides you hopefully with the tools that you have to be able to do this. By separating the logic of the application from the configuration, by using containers, and by seeing how we can develop pipelines using a functional reactive approach, we can see that we can develop huge pipelines using the best software practices that are portable, reproducible, and usable by everyone. So we'll now jump into the section. We'll take a 10-minute break or so. When we come back, you can go to this website here, where we will find the actual training material that we're going to be using for the course in the next time. So the first thing that we're going to do when we come through. Okay, welcome back from the break. Just point out a couple of things. If you're on the Zoom call, you can feel free to ask questions in the chat. When we go through the more exercises, there'll probably be some questions that come up. If I see them, I'll answer them if they're quick. If they're more longer, I'll have Paolo will be able to answer them for you. Otherwise, we're always happy to answer anything afterwards as well. happy to do this at the end of the session. So what we're going to do now is set up the training environment that we have. And for this, for the people following along on Zoom, we have a AWS environment for Cloud9, which is a integrated development environment in the cloud. So this just enables us to all start with the same environment, and it's got a simple text editor and an ability to run, and we can go through the exercises. For everyone, we can go through, and I'd like you just to go to this link, so sakera.io/training, and when you go to there, you'll be greeted with the instructions on how to do this. So I'm just going to stop sharing and change back onto my monitor here so you can follow along with me. And here we have the Nextflow docs that we have for the training environment. And this will be here for the rest of the week. What we'll also see is actually this material we're going to now open source. So in the coming weeks, you'll be able to find this in the Nextflow website or Sakera website. We just need to clean it up a bit and make it a bit more generic. But for now, we're going to follow through. So we have an environment for the people running on Zoom, and as I said, an AWS Cloud9 that has everything installed. But if you didn't have this, if you had wanted to start, for example, to run Nextflow on your own machine, there's a couple of requirements that are needed for Nextflow to run. So it's compatible with any POSIX compatible system. So typically this means you can run Nextflow on Linux and OS X. There is some people who have been using Nextflow for the Linux for subsystem for Windows. It's not officially supported, so I mean, it's probably not the recommended way to go, but I know that some people are trying it out, so your mileage may vary on that one. In terms of what's required, so we said essentially Linux or Mac OS X. It also requires Bash and Java 8. So either Java 8, 9, 10, or 11. Up to 12 can be installed as well. So those are the core requirements. They're relatively simple, and for most machines, you'll be able to find that and get going. For this workshop, and to kind of run everything in this workshop, there's some things which are needed, which is kind of optional. So you need Docker to be able to do the container section, to be able to run through our actual pipelines. This is because we're going to use Docker both in the container training session, but also some of the dependencies we need for our pipeline will be in Docker. We also will do a small section on Singularity and Conda, and GraphViz is used for being able to look at, to create the visualization of the pipeline. Very optional, nothing to worry about if you don't have that. So for the people that are following along on Zoom, we're going to go through and launch our cloud environment. So this is a console that we're going to log into, and each of us has a username here. So you have your username here, which is going to be your first name as the I'm a user. Okay, so what you're going to do is we have set this up now. Sorry, it's a long list of people. So we have set this up here with EU Central 1. So when you click on this, you're going to go through and log in with your username from above. You're going to have to put this account ID number as the first thing that comes in here. I'm already logged in, so it's not going to work for me. And then there is the password, which you'll be able to find in the Zoom chat. So in the Zoom chat, you'll find your password to log into that. So we're going to use AWS EU Central 1 here. So this is in Frankfurt. It shouldn't matter too much if you're based somewhere in Europe. Otherwise, if you're outside Europe, there might be a slight delay in the connection that you have. Once you log into the environment, we're going to be greeted with the login here. So we have Cloud9 environments. Your environment may look like this. So it may be your username here. And what I want you to do is just to go to this Open IDE here. When you click Open IDE, it's just going to take a moment to load up. And this is now essentially a virtual machine that we have in the cloud that we can use for running this. I'm going to give you a couple of minutes to run through this and just give you a few minutes to get everyone onto the like, maybe if people can write into the chat when they are done, so I can get an idea of once you're into the chat, once you're into the environment, sorry, and that everything's connected, if you can write done, then I can just get an idea of when to move on. Okay, it looks like people are getting set up. It's good to see. So today we don't need to use the environment a lot. We're just going to do a very short session to essentially get you set up. If you do have problems, we can join a bit earlier tomorrow, or we can discuss that and get you set up if you have any issues. So don't worry if you miss out too much. We have to do the environment setup once, and after that you're all good to go. So don't feel like you're being left behind. It's more important if they focus on the material than get the environment setup done. If you do have any issues as well, Paolo will be checking the Zoom now, can hopefully reply to you. Okay. So to set up the environment, once you do have the IDE loaded, so once we've got the Cloud9 going, we have a series of commands that we just have to copy paste into here. As I said, you just need to do this once. So you can follow along or do this in your own time. The first thing that we need to do is to take all of the training material. So we have all of the scripts we're going to use over the next days, all of the data, and a few other things that we have, which we're going to be using. And don't worry about having to copy this. We're going to be able to use this and provide this to you after the course. So this will be available and this will be up for the rest of the week, but we will also provide it to you at the end of the course. So if there's anything you don't get, you want to go over again in your own time, yeah, don't worry about that at all. The first thing we want to do is take all the training material. In this case, the training material is going to be here. So we're going to do an AWS S3 sync here. Let me just try this. I'm going to go and pull my environment closer here. And what this is doing, you can see, is just pulling all of the material that was required that we have. So we have a series of scripts. We have some exercises, some data, and some docs that we have. Okay. After we've synced this material, we want to do a setup of the environment. Run through this here. This just takes a few minutes to run. I see there's some people having some issues with unable to locate credentials. As I said, don't worry too much if we can't do it right now. We can set that up for you afterwards. So this is just installing Java that's required, as well as a few other requirements that we have for running this environment. I would say one other thing to check if you cannot see the IDE button. So sometimes if you already have an AWS account, it may log you into your own one. So make sure that you're logging into the one that's provided in the material. And also when you're here, make sure that you are selecting the region. So we are in EU Central 1. So make sure you see that there, otherwise you will not be able to, you won't see that. So make sure that you select the one that you have here. So when I, for example, select that and I see the account environments, I should be able to see all of the users that we have here. And then you can say Open IDE on the one that's related to you. So almost complete there. Okay, and the last thing we did there was just pull a container, which we're going to be using for the rest of the workshop. And the final thing to get set up. So there was three things to do. We had to sync the data. We had to set up the environment. And then we had to install Nextflow. So to install Nextflow, we're going to do a curl. This is a command that we can run in any command line to install Nextflow. And then the second command here is to move Nextflow onto the path. So this means that we can have Nextflow in a position, a location that we can call it and to run. So this is something that you would do on any machine. This is not specific to the environment now. So I'm going to just raise this a bit up so we can all see. So the first command I would say is curl get Nextflow. This creates a file called Nextflow in my directory wherever I run this. And then I'm going to simply move Nextflow onto the path. So we have our path includes bin. And when I run this here, this moves Nextflow onto the path. And now to check that you have Nextflow installed, you say Nextflow info. And with this, we can see that we are running the version of Nextflow. So the versioning of Nextflow works that we have the year, and then we have the release. So this is 0.04. So this is from April. And you can see that we have a second number on here. And this is the edge release. So Nextflow has two different releases. It has a stable, which comes out every 3 months. And then we have an edge release, which comes out every month. And it's just a matter of how stable the features are that go into that. Typically, I mean, this for running in production, you would be wanting to use the stable stuff. For everything else, the edge is perfectly fine to use. Just gets the features a little bit earlier. Okay. So that's everything that we have got started. I think if you're having any issues, as I say, maybe we can chat after this, after the end of this, the end of the course, say the last 10 minutes or so individually with people, and we can get you sorted and check your accounts individually. For now, we're going to focus on just creating a first Nextflow script, going through the individual parts, and then understanding how we can pull it all together. So the basic concepts of Nextflow. One thing that I didn't really stress at the beginning is what Nextflow is based around. So one of the ideas is that people are using Linux more and more, and Linux can be thought of as the lingua franca of data science. So this means that we want to be able to chain tools together, and it's using the same way that people use Linux and command line programming and scripting. But we also want to be able to do this in a way which facilitates parallel computation. So computation in a distributed manner. And that's where kind of Nextflow comes in. So about enabling these workflows that are portable, but whilst at the same time using them, using the underlying Linux system. So the key concepts that we will be going over are processes and channels. Processes and channels are the main parts of your Nextflow pipeline, and they're the key concepts to understand. Processes are relatively simple to understand, but I would say channels and the operations on channels are probably the most difficult part of Nextflow. They are a part which takes a little bit of getting used to, and something that we'll be spending a bit more time on. So processes are our individual tasks. You can think of them as like if you want to run a particular tool, this could be as a process. And they're independent from each other. So when individual processes run, individual process meaning tasks, they're essentially not being able to write to each other. This means that we can use the channels as themselves to pass the data from each process to another. And we do that by having the processes have defined inputs and outputs, and the inputs and outputs themselves are channels. Okay. I've already stressed this a bit before about the execution abstraction, so separating out the logic from the actual execution environment. And you can see here basic information on Nextflow itself. So it's domain-specific language. So we are writing a language which has been created, which allows us to create a syntax for developing our Nextflow pipelines. And it's written on top of Groovy. So Groovy is becoming increasingly used actually in many programming languages. And it's a relatively simple syntax to get used to. You could, as I say, you could think of it as Python for Java. If you're familiar with Python, you should not find it too difficult. And likewise, you can also access Java underneath if it's required. What we're going to do now is look at a first script. And this first script is going to contain a little bit of everything. And it's hopefully going to teach us some of the core concepts of Nextflow and get us started. The first thing we're going to do is look at a script. It's called hello.nf. And first thing you'll note is that Nextflow scripts are just text files. So you can use any text editor to create a Nextflow script. And by convention, we name them with .nf. So for example, we write the script is going to be hello.nf is the name of the file. The first line here is a shebang declaration. So this just is just to say, if you don't define what to use, it will use Nextflow to execute the script. This is not necessary, but just as useful for defining that. And the first line that we see is a parameters definition. What we're doing here is starting with parameters. This is the start of your pipeline. You typically will define the inputs of that pipeline. So in our case, we're defining a parameter which is called greeting. So we now have a parameter named greeting, which is just simply a string, hello world. The first thing that we do is create a channel from that parameter. So typically to place data into our processes, we should define it as a channel. And what this means is that the greeting, so the string, which was hello world in the first case, now becomes an element inside this greeting channel. So this greeting channel in this case just contains a single element, which is a single string, hello world. And this greeting channel will be the input for our first process. So we can see some core concepts here. We have a parameter, we have a channel, and we have our first process. This process block begins with the keyword process. We have a name, what it's called. In this case, it's split letters. And we use this curly brackets then to denote the start of the process. A typical Nextflow process has 3 blocks to it, although there's several more we'll see when we come to processes later on. What you typically see will be an input section, an output section, and then a script section. This is the command which is actually being executed. What we want to do in this process is split the letters. So we have a string as an input, and we'll get to exactly how that works. But think about just for now, the first process that we're doing. I want to explain to you, this is just command line. So this is just printf, whatever the variable is, and then splitting the string here into bytes of 6. So essentially into 6 characters. And it's going to create these chunks, which are going to be different files. So this split is a Unix tool that creates, that splits strings into files themselves. Okay. So when we see this, we can run through, and I'll just show you how this would work. So imagine that we had, in the command line, we had printf. So printf hello world. This is essentially what this is happening. Printf hello world. And then we're having this. When we do this, we can see that there is some files called chunk AA and chunk AB that are created. And if I was just to look at those, you can see that the first one's got hello, the second one's got world. So now we understand a little bit about what the actual script section done. Let's go look at the Nextflow process itself. Okay. So the Nextflow process, we have to define the input to it as well as the output to it. The input is simply a value, in this case, the string hello world. And it's coming from the greetings channel. Notice the syntax is always the same here. Input, the type, a variable, and then from a channel. The same thing here. The type, in this case now it's not a value, but a file. The actual name of that file into letters. Letters is a new channel we create here. So you'll see this repeated again and again. We have a type, the variable from the channel. Notice though that this X here, which is the string, in our case, hello world, becomes used inside the script with a $sign. So this X now is a Nextflow variable. This is important to notice. So whatever we have from the channel become part of this. Okay. Likewise, with the output, we've seen that this process, when it runs, creates two files, chunk AA and chunk AB. And they're now going to go into this letters channel. Let's just start with the first part of this process. And let's start running. I think I can just, I'm just going to delete this second section here first so we can see, just focus on a single process. So we should have a pretty good idea of what's happening here. Okay, I'm going to save this and we can run our first Nextflow pipeline. We can say, to run a pipeline, we say Nextflow run, and then we just put the script name. In this case, hello.inif. We launch this, and you get told some information at the beginning. We get the version that we ran. We get launching of the script. We also get a unique name here. Notice that this name changes every time I run the pipeline. If I run it again, I get a completely new name that gets made. The other thing we'll notice here is some key information. So first, we get this funny number here, which we're going to go back to and explain. And notice how these numbers are different. We have a definition of the different processes we ran. We only had a single process here, split letters. And we can see that it ran once, and 1 of 1 is complete. So now we can see that we ran split letters once, and there was one task of it, and it completed successfully. So that's all good. Now we want to consider a situation, where is these chunks gone? We want to now use these chunks which we created. In the first case, remember that we had them here when I ran them in my file, hello and world. Where are these files now? I'm going to remove them from here. Run this again. I'm also just going to remove my working directory, which I'll explain in a moment. Okay, so removing these. Now let's look at this. Nextflow run, hello.inif. But what I want to do is find out where these are and what contains in there. And the way I can do that is to view the contents of the channel. So we have created a new channel which contains 2 files now, and we want to view where they are. To do that, we can take the channel itself and simply run view on the end of it. Save this file and launch again. When we run this, notice that we have the same as before, a new name here. However, what we're able to see is to view the contents of that channel. And what we see is we get this huge long number here. So this is telling me that the actual files, chunk AA and chunk AB, are now in this location here. Okay, why is that? What's happening? Well, you can remember at the start, we said that each Nextflow task will be created and will have its own working directory. But what this means is that for each Nextflow task that we have, it has its own working directory, and the files that are created in that task will be in that directory. And this is exactly what's happening here. You notice that this is creating two files, and it's in this work 01, B8, etc. This is the location of them. Another thing to note is the location, the number here. And what this is a hash. This is a hash which is created from the inputs of that task, and it becomes very useful for us for doing the resumption of the pipelines, which we'll see in a moment. Okay, if I wanted to see inside there, I could go into that. I could do ls on my work /01, B8, etc. And you can see that these are the two files that have been created there. All good. Now let's think about, we want to do something downstream from this though. We've created these two files. Now we want to perform some modification on them. We want to create a new process which is going to manipulate them in some way so that we can use them downstream. What I'm going to do now is go back to the original flow that we have here, and we're going to create a new process. And what this new process is going to do, what this new process is going to do is going to take the previous setting here. I'm just going to call this channel to be a bit more clear. It's going to take the letters channel, which we've just created, and it's going to use it as the input for our next process, convert to upper. Now, this syntax is slightly different here. You can still see it's the same. We're taking a file, which is the type. This means that remember that we created chunk AA and chunk AB. These are files, no longer strings. We can define a new variable now. We're going to call these files Y, which will then be placed inside the script section here. And we're going to say from letters channel. And notice now we have an operator. What this means is we're taking the channel from above and we're performing some operation on it. We'll see exactly why in a moment. The script section itself will just cat that file, and it will pipe it to a tool which will convert the lowercase letters to uppercase letters. We can see that will happen there. And then once we do that, we'll then be able to view the result of that. So to view the result of that, we're going to do something similar as before. We can use result.view, or we can do a trim as you prefer. This is just to show you the different ways that we can write this. So I'm just going to stay with result.view, and we should be able to see exactly what happens here. So now I'm going to run the pipeline again. So save that and run .hello. And now you'll notice something. We can see that the process split letters ran once, but convert to upper ran twice. And then we can see the result of this, world hello. I'm going to close this and just run this again. Now I've got hello world. Notice how the order of world and hello changed then. And the reason for that is that the process, the two tasks of the convert to upper process were running in pure parallel. So they were completely parallel to each other. And therefore it's not determined which would be created first. It's not predetermined which of hello or world would be generated first. And we can see that when you run that, this is showing you that the processes are running purely in parallel. Another thing that we can do here is consider that we wanted to change this up a little bit. Imagine that we were writing our pipeline and there was an error, or all of a sudden we didn't need to simply cat the result and change to uppercase, but imagine that we wanted to reverse the string. So instead of saying world hello in uppercase, we wanted to change this to something else. If I was to simply change the second process only, so now I'm changing the second process only, and I'm going to make it do the reverse, not catting it, but the reverse of that. So I've changed one line in my script. And what I'm also going to do here is introduce the use of resume. When I use resume, what you'll notice is that we've got this again. The hello and world are now reversed for us. But notice that the split letters process here is cached. The split letters process, or task in this case, did not actually run. It was being able to know that it had been run previously and that nothing had changed. If I was to change one line or one piece of code in here, imagine if I was to call it chunks instead of chunks. When I run resume here, you notice it will run the whole pipeline again. Oh, sorry, that's going to be looking for another file now. So I have to, this is an error telling me that it was looking for chunks something, and I created chunks. So I'll save that. When I run this, you'll notice the whole thing begins from the beginning. So in this case, that's not right. Save this one here. If I was to do resume again, you can see that both of them are cached. So I can do resume as many times as I want. The fact that these processes are linked via the channels, and the fact that we're able to determine which process is changed, means that we're able to resume our pipeline from any point. And if the task is not changed based on the script, based on the input data, etc., we're able to resume the pipeline in that manner. What I also want you to know, when I run this twice, the process here has the same task working directory. So the split letters task lives in work 24, F9, etc. The same thing happens here. So it's the exact same task. Nothing has changed inside that task working directory. And the execution has essentially been skipped once it's assessed that that has happened. Okay. Another thing that we can do that we look at this is, so we've seen that they have the ability to create these things in different order, that we have this hexadecimal number, that this is the working directory. These are created based on the inputs. We'll see a little bit more of that later on. We can modify and resume a pipeline by changing the second process here and split that. Another thing that we can do is to change the actual parameters of a pipeline. So what we didn't show you is we created this greeting here. Just going to copy this one here. We notice that the third line that we have here is params.greeting. And this params is a special scope for parameters. And parameters are special in Nextflow in the sense that they can be defined in several places. This means that I can change an input parameter from the command line. I can also change it in a config. And like we have here, where I've defined that parameter in a script. So here, the parameter is defined by hello world. It's defined in the script. If I run this, save this and run this here, we can take off resume here. It's going to be using hello world as our input. However, we can overwrite that by saying this. We can say Nextflow run hello, and anything which is a parameter here, for example, .greeting, we can use this to here to say greeting and then override it from the command line. So this dash dash parameter name can be used from the command line. Notice that this dash dash is different from the actual core Nextflow command. So core Nextflow commands are used, for example, dash resume. So single dash for resume, double dash for parameters. And these are parameters which you define your pipeline. So some of them are pipeline parameters, some of them are core Nextflow parameters. Keep that in mind when you're going through that. Other things that we want to note there. So I'll just recap this script section, and then we will jump in and see if we need to help anyone else out before we start on the kind of core channels and the like later on tomorrow. So from the beginning, we can define parameters within this params. We can create a channel using a channel factory. In this case, this is channel from, creating a greetings channel. That greetings channel is the input to the split letters process. We run the script here. It just runs once because there's a single, it's a single element here that runs through here. What I didn't explain is this dot flatten operator. Let's try run this once. I'm just going to go back to the original script because it's a little bit nicer in terms of creating the output it creates. It'll be a little bit simpler to follow this along. So I'm just going to use the original script that you have in hello.inif. I'm going to save that. And now we're going to see the kind of first part of the data flow programming aspect of it. Let's just run hello here. Okay, so we get hello world. What I want to show you is what's actually happening in this first process is that we are creating and split letters here, two files, but those two files are actually a list. It's actually a list or a tuple of two files, and the letters here actually contains one element. This means that when we run through this, if I take off flatten here, I've actually got a list of files. Let's do this, save this. So all I've done is removed .flatten. I'm going to clear this and run. Notice here that convert to upper only ran once. So this means that the convert to upper was simply run as a single task in its single working directory. Why is that the case? Well, again, I'm going to cut this out and just show you again. Letters.view. Whenever you want to try to understand the pipeline, it's very useful to understand the makeup of the channels that are going into the processes. In this case, we want to understand what does letters have? What is the process inside letters? What is the makeup of the channels? We remember before it's two files, but how are those two files structured? Notice that there's some square brackets here. This means that this channel contains one element that is a tuple of files. Imagine that I was having what we had before, flatten. When I perform what's called an operation or operator on this process, I save this. Now let's have a look. Notice how it's no longer inside the square brackets. That now it's a channel that contains two elements. Each of them is a file. Above, I got a channel which contains one element, which is a tuple of files. So the fact that we now have two elements means that the makeup of the channel, the structure of the channel, drives the execution. It changes the way that we execute. Putting this all together, we now say convert to upper by itself. So this is without the flatten. Because this is simply it contains just a single element, we get this run once, changing it to flatten, we see that convert to upper runs twice. So this is something we're going to stress more and more and more. Don't worry too much if you don't get it. It takes a little bit of understanding, but what we're showing you here is that it's the structure, it's of the channel that drives the execution, which changes the way we execute things. And therefore, it's the way that we write Nextflow pipelines is to create these channels and structure these channels in a way that we're able to connect up the various pieces. I think for that, that's where we're up to for today's session. I don't want to jump in too much because tomorrow we will go directly into actual channels themselves. To processes, we'll jump a lot deeper into that. If you have any, if you do have any questions, though, I'm happy to open up the floor, and we can, if there's anything that we want to go over for the last 10 minutes or so. Otherwise, feel free to write questions in that. I can see if I can have a look through some of these. So one of the questions here is, will convert to upper process start to run when all the parts of the letters is created, or can it identify when one element is created and available to start running? So I think the question is, imagine that our first process here, this is a good question actually. So imagine that this first process or the second process, imagine that we had a process which split, which needed to run multiple times. Imagine split letters had, for example, our parameter here was no longer a single file, but it was a list of files. It wasn't just hello world, it was multiple of them here. We can demo this hello world, and then imagine that we had something else. I think I'll take the example from before. I'm just going to modify the pipeline a bit. What we're trying to get at here is, does the split letters channel need to, or does the downstream process need to wait for all of the upstream processes to complete before it runs? And the answer is no. So as soon as the execution, as soon as the channel has something which it's able to perform, which is essentially meeting the criteria for execution, the next downstream process runs. So this means you don't need to wait for all of the upstream processes to complete before the next downstream processes run. And I can show that here by saying, imagine that we had two processes, so split letters had to run, and that we were to save that there. This may or may not work. Might need to do of here. Okay, this worked fine. Okay, so you can see that now we had two greetings. So you can see that this one was hello world, one was bonjour le monde. And that means that the inputs here, there was two of them. So process split letters ran twice, but the downstream process convert to upper was not necessarily waiting for all of the two tasks to complete before it started running each of the convert to upper. What we're creating here in the letters channel now is no longer two files, but we would be creating 5 files, and that each of those 5 executions of convert to upper would launch as soon as that element, in which case it's just a file, entered this letters channel. Okay, another quick question there. So what does the 1 and 2 after the process name and the output mean? So you can see here, in this case, we have the different numbers. What this is saying to you is it's actually the number of that process. So we ran in total 7 tasks here. So the first process ran twice, the second one ran 5 times. And this is just the actual number you have there. You can think of this as, we can see that we can actually change that number. The number is just the number of the tasks, but it's not particularly useful for you. What we'll see tomorrow is we can add something in here that's a little bit more useful. Imagine that we wanted to change that number. and let's do something like, you can do a tag. And with that tag, we could say, for example, the name of the file. This will replace that number with something more informative. This could be good to do as like a sample name. So you can see that now the tag has been changed from the number to the actual parameter itself. Another question there said, if you specify dash dash anything, will it be interpreted as params anything? That's exactly right. So imagine that we had params dot anything. And then I'm just going to cut this out. This would be whatever you like. So this could be say Z. From here, I could then write Nextflow run, hello, and then I would write here, and I could overwrite this from here. So this is just a way of defining what the parameters are, and you can define it, actually, to say in the script itself, from the command line, or also from the Nextflow config. Okay, another question that we have here is if one channel can only have one consumer, how can many different parallel analysis be executed on the same input? Well, there's a couple of ways of doing this. I think the idea would be, I think the question, sort of rephrasing it, would be, if imagine that you had a single file and that you wanted to run that file on many different analysis. There's a couple of ways of doing this. One would be to use a value channel, which we will see tomorrow, but a value channel is essentially can be consumed multiple times. Another way to do this is to construct the channel yourself. So imagine that you have a file and that you have 50 different parameters that you want to run an analysis with against that file. You could create a channel using operators which contains both that file and each of the 50 parameters. So a channel with 50 elements in it. That was made up of that, and you can see how you do that with an operator. This is a little bit beyond the scope of the first day, but in DSL2, there's no longer a requirement to that the channel can only be consumed once. I think it's a slightly different question to that. Hopefully that answers the question. We'll see examples of this. So a typical example of that would be like, imagine that I have a single reference file, like a genome reference, and I wanted to use that against, or I used to run that against all of my samples. So the index may just be a value channel, contains just the index itself, and then all of your samples would then be in a different channel. We'll see how we can combine that. So yeah, going back to the beginner's question there about was bash was mentioned as a dependency. Yeah, so we have bash and Java are the main dependencies that are required for running Nextflow. Do we need bash default shell, or just the availability of bash is enough? I'm not sure on that one. I would defer that to Paulo. You can jump in. I know on like the new Mac, they have a different default shell, but I've been running through that, I think, with no issues. Yeah, so there's like some comment that using fish as default has been fine. All right, I think if that's all, we can adjourn for the day for now. We'll see you back again tomorrow at 9:30. As I say, switch over to the NF Core YouTube channel onto the events page. I can show you that. If you go onto NF Core events, you can see you can register there. They have a whole bunch of very interesting talks you'll be able to find. They'll also be available on a YouTube stream. It's just a slightly different YouTube stream. You can see below on how you can find that. There's some projects if you're interested in jumping straight in to jumping into the panel. Also, I'd recommend joining the NF Core Slack. community there. On there, you'll find lots of information about the hackathon and a whole bunch of really useful stuff. You can see the various different projects that they have here, but I don't want to go too deep into that. I'll leave that to the fine people over there. Thanks a lot for your time all, and I'll see you tomorrow.